In this video, we're going to look at complex numbers. So we're going to start by talking about an imaginary number. And so previously we looked at some square roots of negative numbers in solving equations. And when we did that, what we said was it was not a real solution or it wasn't a real number. And that's still going to be true. But now what we're going to do is we're going to introduce a new set of numbers. And so when that does happen, we'll be able to work with it a little bit more. And that new set of numbers is called the imaginary numbers. Okay, so we're going to look at the imaginary numbers. This is going to include what we're going to call the imaginary unit, which is I. Okay. And so the imaginary unit, which is I, is the number whose square is -1. So that means that when you square I, it's equal to -1, which means that I is going to be the square root of -1. So these two things are very important. Okay, so let's look at how we can use this to do some operations, some simplification of some radicals. So if we had this and we think about, remember our rules for simplifying radicals said that if we had A times B, we could write that as the square root of A times the square root of B. So what we could do here is we could split this up and we could say that that is the same thing as -1 times 64. And so I could rewrite that as the square root of -1 times the square root of 64. And like we saw on the last slide, the square root of -1 is I, and the square root of 64 is 8. And so we're going to write this with the I in the back. So 8I would be my final answer here. Okay. All right, let's do the same thing with the next one. So again, I'm going to start by simplifying this. I'm going to break this up. So I want to first start by making that as a -1. And then I'm going to think of this as 160. Now, 160 is not a perfect square. So I can continue to kind of break this up a little bit more. And I can say that that's -1. I can pull out a perfect square of 16. And then I can write that as 10. And so if I then think about this as the square root of -1 times the square root of 16 times the square root of 10, what I've got is square root of -1, which is I, square root of 16, which is 4, and then the square root of 10 is left behind. So now if I rewrite this in the correct order, I'm going to have my 4I and then square root of 10. Now, we want to look at what's called complex numbers and the standard form of those. So when you're looking at a complex number, okay, a complex number is going to be a number that's written in the form A plus BI. Okay, so we're going to have two parts. A and B are both going to be real numbers. A is going to be the whole real part. Okay, so that's going to be our entire real number. BI, so the part with the I, that's going to be the imaginary number. So the part with the I is going to be the imaginary part. So you've got a real part and an imaginary part. If B is equal to 0, the I is not going to be there. So that's going to be a real number. If A is equal to 0, the real part's not going to be there. It's just going to be an imaginary number. If both pieces are there, it's a complex number. It's going to have a real and an imaginary part. When we're adding and subtracting these complex numbers, what we're going to do is we're going to add and subtract the like parts. Okay, so that means if we've got A plus BI plus C plus DI, The A and the C are our real parts, so we're going to combine those. And then our BI and DI are the imaginary parts, so we're going to combine those. The same thing with the difference. So when we subtract, first thing we want to make sure that we do is distribute that negative. So we're going to start by making sure that we change both signs, and then we'll combine our real parts and our imaginary parts. So let's look at some examples. So we want to start by performing the indicated operation. In this case, it's addition. And then we're going to simplify and write in the form A plus BI. So we've got 7 minus 6i plus 8 plus 8i. So I'm going to start by combining my like parts. So my first real and real parts, I've got 7 plus 8. Those parts we're going to combine together. So the 7 plus 8 gives me 15. Then I've got minus 6i and plus 8i. So together that gives me plus 2i. And that's it. Okay. The difference, I've got to make sure I distribute this negative. So our first step here we want to do is rewrite it so that I can distribute that negative. So that's going to make that a positive 5 and a minus I. From here, I can combine my like terms. So I've got a real 3 and the real 5. So that gives me 8. And then I've got plus 7i minus I. So that gives me a total of 6i. Okay. All right, the next thing we want to look at after we talked about adding and subtracting, we want to look at multiplying. So when we multiply two complex numbers, if they're in the form A plus BI, we need to multiply it just like we're multiplying binomials. That means we're going to need to FOIL. We're going to need to distribute everything. So we're also going to make sure that we use this relationship that I squared is equal to -1. So let's look at what happens. So we're going to simplify. We're going to multiply here. Remember, when we have something squared, we always want to write that 2 times. So the first thing we're going to do is start out by writing 9 minus 7i times 9 minus 7i. I'm going to multiply that through. So 9 times 9, got 81. 9 times -7i, so minus 63i. Then -7 times 9, so -63i. And then -7i times -7i. So that's going to give me a positive 49. Then the I times I is going to give me I squared. Now I need to clean things up. So I've got 81. My -63 and -63i, that's going to give me a minus 126i. And then plus 49, but I squared is equal to -1. So really what I have, 81 minus 126i, I've got 49 times -1, so really that's minus 49. And so I can combine this 81 and -49 to get a final answer of 32 minus 126i. Okay, let's look at another one. So here again, I'm going to start by distributing. So I've got 6 times 6, so 36. Got 6 times -2i, so minus 12i. -2i times, positive 2i times 6, so plus 12i. and then 2i times negative 2i, so minus 4i squared. So we're going to clean that up. So 36, can combine these. I've got negative 12i plus 12i, so that's going to give me 0. It goes away. Then I've got minus 4. I squared is negative 1. So if I combine those, I've got 36. Negative 4 times negative 1 becomes plus 4. And so my final answer is 40. Okay. And so if you notice here, the middle term canceled. It went away. And then I also want you to notice a couple things that we're going to talk about in this next slide. But if you look at our terms, we've got 6 plus 2i, 6 minus 2i. These are the same. These are the same. The only difference is this sign here. Okay. And so that leads us to the complex conjugate. And we talked about conjugates in the radical section. We're also going to use those here, okay, with the complex numbers. So complex numbers a plus bi and a minus bi are conjugates. Okay, they're called complex conjugates. And so what happens when you multiply those out is that middle term is going to cancel out. And so a plus bi times a minus bi is going to be equal to a squared plus b squared, which is what happened in that last example. Okay, let's get a couple more examples. So here we want to make sure that we're simplifying and multiplying. It's really important that you simplify radicals before you multiply them when you are working with negatives. Otherwise, you may lose a negative. So the square root of 36, we've got 6. The square root of negative 1, that's I. So I'm just left with 6i. Okay, number 8, going to distribute this through. So I've got 4 times 4, which is 16i. And then 4 times negative 9, so minus 36. I times I, so I squared. And clean that up, so 16i. It's going to be minus 36 times negative 1. So that leaves me with 16i plus 36. Okay, now sometimes the systems can be kind of picky. And so since it asks us for our answer in a plus b I form, it wants that real number first. So 36 plus 16i would be how we want to write that. All right, now we've looked at I and we've looked at I squared, but sometimes you may have more exponents that are a little bit higher. So let's look at what happens when we have exponents for I that are a little bit higher than 2. Okay, so the first one we've got is I, which we said was the square root of negative 1. Okay, so that simplifies to just I. All right, I squared. So if I were to take that square root of negative 1, right, and square it, remember our squares and our square roots cancel, and I'm just left with negative 1. So I is I, obviously. I squared cleans up to negative 1. Okay, we've done those two. Let's look at I to the third. So in I to the third, I could rewrite that as I times I squared. That's equal to I to the third because we can add those exponents. Okay. So then if I say, I'm going to keep I, but I squared I know is negative 1. So that would then simplify to negative I. So I to the third power is the same thing as negative I. Okay. What about I to the fourth? Well, we could write that as I squared times I squared, which is negative 1 times negative 1, which is positive 1. Okay. All right, let's look at I to the fifth. Okay, well, I to the fifth, I could rewrite that as I to the fourth times I, and I to the fourth is 1 times I, so I to the fifth is the same as I. Okay, I to the sixth, well, I could rewrite that as I to the fourth times I squared, and I to the fourth is 1. I squared is negative 1, so I to the sixth is negative 1. I to the seventh, I could rewrite that as I to the sixth times I. I to the sixth, we said, is negative 1 times I, so I to the seventh is negative I. I to the eighth, I could rewrite that as I to the fourth times I to the fourth, and that's going to be 1 times 1, which is 1. And if you look, you should see a pattern. This pattern is going to continue to recycle, okay? That means that I to the ninth is going to be I to the 10th, I to the 11th, and I to the 12th, I to the 13th, 14th, 15th, and 16th. So it's going to continue to recycle each multiple of I to the fourth. Okay. All right, so if we look then at this example, we've got negative 3I to the fifth. So I'm going to take that 5, and I'm going to say, well, we're going to take negative 3 to the fifth power and I to the fifth power. So negative 3 to the fifth power is negative 243. I to the fifth power, I can simplify that. So if I look back at my multiples of I to the fifth power is just I. So what that means, this will simplify to negative 243I. All right, one more thing we're going to look at is a complex conjugate. So this is very similar to when we were rationalizing the denominator. And when we did that with a rational expression with radicals, we multiplied by the conjugate of the denominator. So when we're dividing complex numbers, we're also going to use that conjugate when we're dividing, okay? So for example, if we wanted to divide 7 by 9 plus 5i, we are simply going to multiply by the conjugate. So that means I'm going to multiply by 9 minus 5i, numerator and denominator, just like we did with radicals. So in the numerator, I'm going to distribute. So I'm going to get 63 minus 35i. The denominator, going to multiply that out. So I've got 9 times 9, 9 times negative 5i, 5i times 9, and 5i times negative 5i. Okay, then we're going to clean that up. Remember, conjugate makes these two middle terms cancel. That's why we use it. So 63 minus 35i in the numerator. Denominator, I've got 81 minus 25 times negative 1. So I've got 63 minus 35i over 81 plus 25. So final answer, I've got 63 minus 35 over 106. If I could simplify that, we would want to. And I forgot my I and my 35. There we go. That looks better.